If someone happens to knock it off, it is recording, okay? It will, well, the link will go on, yeah.
Welcome to University of Greenwich. Welcome on behalf of the Chancellor's Institute of Building. Those of you that know me know I'm dual hatted this evening. I sit here as a lecturer, or I stand here as a lecturer for the university on this campus, and I'm also a long-standing member of the CIOB London branch. There are some of my colleagues from London branch, and as I'm speaking, I can't find one. There's Barry Savage. Someone else put their hand up, Andrew Stanley somewhere, Andrew Maylou. Yes, there are some more as well. Our administrators, our branch manager, Sam, is outside. She will be welcomed you along with Marie. We have a thoroughly active series of events as part of London branch CIOB. If you're not a member, I encourage you to at least look at our website. We are open to all in terms of the event and the attendees. The domestics for this evening, there are no planned fire alarms. So if you hear a fire alarm, Mervyn will probably run that way and I'll run that way, and we will convene on the grass outside by the river. The facilities, and I'm sure some of you have found those already, are second archway on the left and third archway on the left. This evening's event is particular to building information modelling. It's a subject that I lecture on in a very novice way. I have the expert for you this evening. I've had the pleasure of listening to Mervyn present previously. Mervyn, you will note, is an OBE. OBE for Services to BIM. And as Richard, one of my university colleagues, has already got quite excited about, this is the man that wrote or drew the diagram that he's been teaching to his students all of this week. So you could not get a more famous presenter this week than Mervyn. I'm giving you a terrific build-up. So, without further ado, less from me, I present to you Mervyn Richards. Mervyn Richards OBE, who is going to present to you in terms of
That was actually part of the presentation. Basically what it comes down to is if the IT doesn't work, everything else falls apart. So yes, me. Who am I? As soon as I manage to find for some reason or other, computers, that's it. Okay, sorry, it takes a little bit of a delay. Sorry, where was I going to start? Threw me for a minute there. Okay, who am I think is the best start. And we don't seem to have any microphones, so if you can't hear me, please put your hand up and say, that was a thumbs up. Yeah, okay, good. It's when it goes the other way that I get a little bit concerned. Okay, so who am I? My name is Mervyn Richards, as you can see there, and OBE in this particular sense stands for an old BIM expert. So there is no doubt of what I'm talking about. I started in this business as a structural engineer, and strangely enough stuck up on a site in Harrogate, painting steelwork with a brush, everything red. And very soon moved on until I was working for a main contractor in 1972, who bought in this thing called a computer-aided design and drafting. It did not have a screen. So you have to think about that, because when you're trying to produce drawings on a computer that has no screen, and you're only doing it with coordinates, feeding in coordinates and telling them to lift the pen up, put the pen down, it exercises the brain to do things right first time. And you're going to find this all the way through the presentation today. It's about good information, good quality information, and doing it right first time. So by the time we get round to 1974, the computers came in that did have a screen. Unfortunately, they had a tendency to glow green, and the ladies in the design offices were all given aprons to wear to protect them. The men, your hair just went grey very quickly. So these computers were very hard working, had hardly any power, and that's what we were given to draw with. So we were having a light pen and a flickering line on the screen. That's where we started from. Okay, what people don't realise is that by 1976 we actually were doing everything in 3D. We very quickly got away from the idea of producing drawings, and we moved into 3D, which I'm going to come to in a moment. Before we start there, I'll pick up this thing on BIM. BIM has been put out there by the vendors as something about 3D modelling. Yep. Now, producing visualizations, and what we're going to be looking at is as far from that true as you could possibly get. BIM, in the way that the government is pushing this and the way it will emerge, takes away the BIM, throw that away. This is about collaborative working. So this is about teams working together to produce a design and to go out and construct it first time with the minimum of waste. And BIM, as it evolves, and I'm not going to talk about levels 3 or anywhere else at the moment, but where we will go, BIM will actually, and what we know as holistic BIM, this collaborative exercise, is going to change everything in the way that the industry works. At the moment, we look at infrastructure systems, we look at design management, and we really look at those basic pieces of software that do structural, architectural, building services, the MEPs, etc. So it's this little bit in the middle. And that's where we are at the moment. But where it is going and is rapidly evolving is into the use of the data that's generated through this process for lots of other things. Building safety, cost control, planning, design administration, construction administration, procurement in particular, now is looking at what are you going to deliver. I want you to code up everything that is going to be delivered to me, so as it comes on the site I can swipe it, it can feed into my management systems, and it will actually put up bills that says you were contracted to deliver this, procured to deliver that, you have delivered this, I will pay you. We already have on some of our projects, on some of the construction projects I've been on, tags on the individuals. And we can actually track them from a point of view of safety, where they are in the building, and certainly on big building sites. And certainly if there's a lot of depth in the basements, as it were on some of the major projects, Heathrow for instance, we needed to know that the people were all out of the building. But what it actually said was, I will pay you for the time that that person was on the site. So you can see that this data and these very simple things are going to build up a database of information that's going to move right into business systems at the end of the day. Yeah. Procurement, delivery, planning, who's working on the site, safety, where is everybody, did I deliver it, etc. It will affect absolutely everything in the industry. It is going to be the biggest movement for change that we've ever seen. Unfortunately, at the moment, we are stuck in the middle here, trying to get the culture to actually adopt this new way of working, to talk to one another, to collaborate, to work together for a better outcome. And that is a very difficult situation. Once again, throwing away this BIM thing. I didn't use it up here, I'll put it down there. A long time before the acronym was ever thought of, a long time before the first computer-aided design and drafting systems were available, people were actually working at MIT. A man called Nicholas Negroponte, if anybody wants to look him up. He does have a little book called The Architecture Machine. which used to sell at around about £3 a copy, now sells for about £350 a copy if you can find one. Anyway, the point about this work is these people, these students, these postgraduates were looking at the possibility of using computers for architectural design, and I don't mean drawing. What they were looking at was algorithms that would allow the computer to feed back to them a reaction to suggested design requirements. So this area is going to be used for this function, this area is going to be used for that function, etc. So you could lay out the spaces in the building from a functional point of view, an activity point of view, and the computers would then work out the juxtaposition of those spaces according to what they wanted to be used for, what the common areas were, what was the smallest walking distance, whatever. Whatever was in that algorithm, it helped the architect produce a design. The thing is, from that very basic outline of the building, you could then just write a specification. So, what type of walls am I going to use for the external wall? You just type that in as a specification. The systems could analyse these very basic shapes and say, here is a wall, or here is a line, that represents a wall. Is there a room on the inside? Yes. Is there a room on the outside? No, therefore this is an external wall specification, and it automatically put in the wall that had been specified. If it had a room inside or whatever, it would put in an internal wall based on the specification. And then it would reorganise, recompile all of those spaces so that you ended up with the working space that you required once the construction, the architectural fabric was in place. And from that very basic information, you could then schedule it and get a bill of materials, how much external wall, how much internal wall, etc. So you can see, I hope, 1965 we're talking about here, the possibility of this computational activity could actually get information, data out of it very quickly indeed, with some very simple inputs. It's taken us right the way through to where we are now to actually see some of this software, some of these apps coming out on our phones, etc. So it's taken us 50 years to get back to where we started, where the thought process was in academia. So this isn't new by any stretch of the imagination. And that's what we have to understand. 1976. As I said, the 3D models came in. This is a system called Computer Vision, which was one of the first 3D systems that I actually worked on. And you can see by the pixelation on the image there how bad the resolution was of the screens. These were driven by big data general computers in another room, air conditioned, throw a bucket of water over it, keep it cool. Then the maximum computing power at that time could not have been more than 300 gigabyte. If you were lucky, it was more likely to be 300 megabyte. Very small. So what we had to do to produce these models was to cut the model up into pieces. A federated activity so that we could actually build these and manage the bits and pieces as a series of small models that we could view all together. So that model may have taken a week to compile. To generate the visualization could have taken another week with every single computer in the company working on doing that rendering. That's how bad it was. The cost of these systems was about £60,000 a seat, and the salary at that time for somebody operating it was £1,000 a year. So you had to be 60 times faster using this than you were using your slide rules and the normal methods that we had, drawing, etc. An impossible task. So these were used, many of these things were used on very expensive processes. So this is process plant, Petrochem. They could afford it, they needed it, they needed to get these things out. They needed to understand, as they do now, how the plant worked, PNIDs, from twos, which are diagrams that show what the process is, what the components are in that list. So they were using data. The drawing was really secondary to that. They wanted the information and they could afford it. If we move on to 1980s, you can now see the development of this. This is Intergraph, which was, computer vision was actually an offshoot of the Intergraph company at the time. Some people went away and built another company called Computer Vision. However, you can now see that the pixelation of the image is changing. We're getting more definition in the modelling process. But it's still petrochem. Yeah. We've now got slightly bigger machines, we've got bigger engines. It's still taking a dedicated machine, computer and servers in a server room, still has to have buckets of water thrown over it to keep it cool, and the processing time for that might have come down to possibly 4 days. The thing about this is, as you can see between the model I showed you there and the model here, this has got a lot more information. And this is a lesson to learn, and we will come back to it later, that if you give somebody a bigger machine, they build bigger models. Until in the end, the model that they want to build, the technology that they have is not capable of doing. And so you have to come back to where we started, as I mentioned, this federation of the model, splitting it down into small units to manage it. Just throw that in for a moment because we will come back to it shortly. So, the technology was showing great promise, but that promise has yet to be realised. Even today, we still haven't realised the full potential of these systems because we keep using them as technology in itself. What we know is that doesn't work. It has very little impact on the way we work and what the outcomes were. So, this is a technology that could solve some problems. The problems were known about, but nobody actually used the technology to solve the problems. What are the problems? Waste. The BRE did a number of studies showing the problems of waste in the industry, which was about fit. Things did not fit together. The architect's information did not fit with the structural engineers, did not fit with the MEPs. And this was partially due to the problem of the earlier technologies, drawing boards, T-squares, scale rules, etc. You couldn't change the drawings fast enough to keep up with the design iteration. But we had a technology that could, but we didn't use it to do it. Some of the things here, a discrepancy of 10 millimetres in one dimension cost £3,000. This was actually on a staircase, where there were precast concrete treads on the staircase, which were too big by 10 mil, and they hit the internal and external walls. They literally had to grind off 10 millimetres of the precast concrete stairs to fit them in the building. And you can imagine this going every single one all the way up to the top of the staircase. Why did that happen? Usually because people don't check what they're doing, and therefore the lack of spatial coordination can be seen to create waste at around about 10 to 20% of the outcome construction cost. It accelerates the price. We're talking about 73 to 76 because it was done twice. It did not improve in that 3-year period, even though the problem was known. If we move forward to 1982, so I've shown you the technology, other reports were written, sponsored by the government. This one is by Adrian Ritchie and John Ogle, looking at this from the MEP's point of view. We looked at structures, etc., but we've done it again through ISRIA. This time, lack of spatial coordination in uncoordinated MEP documentation creates a cost overrun of 40%. 40%. Now these figures are not idle, they have been measured, we know how they come about. And I can give you an example in a structural steelwork frame at Basingstoke Town Centre. It was a £1 million structural steelwork frame. It was not coordinated properly, it was not kept up to date, it was delivered to site, and the rework was £600,000. A 60% increase due to lack of spatial coordination and checking between the different disciplines information. And we just carried on doing this. It's in the culture, this is the way we work, this is what we're going to do. So, Construction Project Information Committee is a group that came out of government sponsorship during the 1970s, where the government went away and said, okay, we've set up this Project Information Committee, we want you to write the documents to show us what's wrong and how to overcome them. And they wrote them. And they are really lovely books, if you've ever seen them, because they're all nice pastel shades of lime green, pink, whatever. They look great on the shelves. Unfortunately, that's where they stayed. People looked at them and went, oh yeah, of course, we understand that. Nobody wanted to change. Nobody wanted to implement them. One of the things that came out of this when it was floated by the CPIC is that one of the principal qualities of good design is integrity. It is equally true that if the information used to communicate that design does not also possess that quality, then the design itself is placed in jeopardy. And that has a massive impact, because the design itself is placed in jeopardy. It means, possibly, not only can't we construct it first time, but the building, once we put it together, and it's there, will not perform in the way that the original brief suggested. So the outcome, the project that we deliver, may not perform the requirements of the original brief. Important to this, I will come back to it, this is about government soft landings that has now been put into place. The other thing that came out of the Construction Project Information Committee was this statement, which is actually a compilation of some comments that were made in an RICS committee report in 1901, reported through the Tavistock Institute, which basically says that information is invariably, for costing purposes, whatever, is invariably inaccurate, ambiguous and incomplete. Everybody knows it, everybody accepts it, and nobody does anything about it. We just carry on doing it the same old way that we'd always done it. Even though we know this is going back to the mid-70s. Why don't we change it? Why can't we move forward? What does waste look like in this situation? Well, this is two drawings overlaid. One is the architects, and the other one is the structural engineers. Using CAD. I mean, normally, if this was produced on Mylar, plastic sheets, or whatever, as we did with ink years ago, you always used to overlay them, stick them on the site hut window, wait for the sun to shine, and see where the discrepancies were. In CAD, we can do away with that. So why, this is a project, this happens to be the KLM building at Stansted, why is it that we take two drawings, signed off suitable for construction by the architect and the structural engineer, and we overlay them, we get these discrepancies. And we are trying to build something from this information. Are we mad? How much time are we going to spend on site figuring out which is the right one? Now, I've only shown two disciplines here. If we throw the M and the E's and the P's in there, we run into even bigger problems. What's more interesting is why has the structural engineer redrawn all of the architect's outline? Because he's been given a reference file, and all he has to do is to insert it into his own CAD file and then draw over the top of it the additional information that he wants to. But no, he's replicated what the architect has put in it. Why would the structural engineer want to draw the doors? Why would the structural engineer want to draw the doors and put them in a different place? I mean, why? The other thing that comes out of this is, how did this get through the checking process? Why didn't somebody check this? This is another big problem about waste. If we do a straw poll at presentations like this, it's usually 1 in 60 companies have a checking process written down. Well, actually, it's about 4 in 60 have it written down. 1 in 60 may actually apply it. People don't check. And their argument is, I don't have time. I've got to get it out by Friday, and that's what I've got to do. So my focus is not delivering good quality information, it's about delivering a drawing on Friday, right or wrong. And this is something else in the culture we have to change. set of drawings overlaid. This is CAD. You know, why are we continuing to do this? Here we have a clash of registration. Now, why is the structural engineer saying, hang on a minute, the stanchion that I've now designed is actually bigger than the stanchion that the architect has indicated? Why didn't I go and tell the architect about it? Why didn't the architect give me more space? Lack of collaboration, not talking to one another. I'm doing my job, you're doing your job. If they come together, okay. Change management. How did this occur? We have the architect's layout, the red, straight staircase and an angled staircase running parallel with the side wall. The structural engineer, doing a bit of value engineering, says, I can actually give you a cheaper staircase if I just put them both parallel to one another. They did not communicate with one another. It arrives on site, and we now have two pieces of information, and we're not quite sure which one is right. Yeah. It keeps happening time and time again. Usually in an audience where you're out in the industry, I put that up there, everybody goes, I've got loads of those, I'll send them to you. Well, if they've got loads of them, they understand the problem, why aren't they doing anything about it? What is the outcome? This will need fixing on site. Don't worry about it, they will fix it on site. And the contractor loves it. I am the superhero. I can take all this rubbish information that the consultants are throwing at me, I will solve the problem, and it's only going to cost you, Mr. Client, 25% of the construction cost additionally. You have to wonder at this, all of the red painted items are site fix. So, the pipes, we're actually going to run through the middle of this ductwork. It's got to site. What do I do? I cut it, I'll 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 screw it, I'll screw it, I'll screw it, I'll screw it, I'll fix it together, fix it. How much did that cost? Normally, we would see coming out of a construction site with the M&E, at around about 50% of the time on site is standing around trying to come up with a solution to the problem. Why did it occur? It occurred because this was only done in 2D, and nobody bothered to check the height of those against the height of that. Checking keeps coming into it. I did not check it. The duct had nothing to do with me. I put my pipe work in, somebody else should move out of my way. This is not just in this one area, by the way. This happened along the full run of that ductwork, right the way across the building. You can see the pattern emerging. Can I press one too many? No? So, this is what we mean by waste. This is a waste in generating the information. You didn't produce the correct information to me to work from. Somebody else uses my erroneous information and they produce even more erroneous information. Because bad information shared becomes a virus. Once you put it in there, it just spreads throughout everything. What we need is to manage this whole process. At the moment, waste in construction cost and time overruns are normal and nothing has changed since 1976, as I've just demonstrated with CAD. Will the BIM tools be used any better? Can the BIM tools make a difference on their own? What do you think? Well, focus at the moment by the vendors is the use of 3D object modelling has been primarily for spatial coordination purposes and the clash detection. You see it everywhere. Use my 3D modelling BIM tool and do clash detection, the low-hanging fruit. The BIM tool salesman, usually changed there to snake oil salesman in this particular instance, tells us that 3D modelling will solve all of these problems. Anybody see any errors in this 3D model? which can be used for spatial coordination, that can do clash detection. This is a model ready to deliver the drawings for construction. It is off Terminal 5. So even though we put the processes, the methodology together on Terminal 5, and we trained everybody to do it, this occurred. And what we did at Terminal 5 was use clash detection to find out who the people were that were not following the process, not for clash detection. Because we knew if they followed the process, this would not occur. The processes that we're pushing out in the collaborative activity is about clash avoidance, not about clash detection. So, we have not realised the benefits of BIM 3D, even though we are told time and time again, do it in 3D, do spatial coordination, do the clash detection, solve the problems. Nothing changes. It's our culture. We don't want to change. Indeed, I know a better way of doing it. So we now have 57 varieties of a different way to do it. But they all end up doing the same thing. So our dear man here, who I'm sure we all see, is insanity. He's doing the same thing over and over again, expecting a different result. And that's what we do. Given you the dates, 1970s, we know what the problem is, we knew how to solve them, we wrote the books, we put them out there, they were put in the top shelf. CAD came along, we knew it could help us, we knew we could get rid of the waste by overlaying, checking. We don't do it. We carry on doing it the same old way we ever did. What we're doing is doing design and creating information to build from in the same way, culturally, as we did in 1901, 1904, 1905. We're still following those same old processes and principles. However, if we introduce a process and a methodology, we change the way in which we work, the outcome becomes something different. This is Endeavour House, KLM building, the staircase I showed you. 3D modelling plus a process changed everything. We proved that the outcome was a measured saving of 10% of the final project cost. It would have been 20% if we'd been allowed to do it right from the beginning of the process. But we were allowed to do it halfway through the process, and we still made that 10%. We modified the way in which people thought, and we made these processes work. This wasn't just a fluke. We had already done this at Heathrow Express after the collapses of the tunnel, where Sir John Egan, who wrote some of those government reports, and had already said that the construction industry should change and do away with the waste. He was CEO of BAA when these tunnels collapsed. And he came to the construction industry and said, I want a different way of working, I want to deliver this station on time, I want to deliver the Heathrow Express on time, because every day I lose, I'm losing money. I need to be earning money. So find new ways of working. And a team were put together to come up with a new way of working. And I was a member of that team. The outcome of what we did on Heathrow Express showed a saving measured by Anderson Consulting, an American company at the time, who were following what we were doing and measuring the results. They reckoned that we saved 20% as a minimum on the delivery of that project after the collapse. So John Egan said, great, I'm going to put this now onto Terminal 5, and we're going to have those processes there. So I joined the team there, where we started to put these together. The industry, as usual, doesn't believe anything. But Heathrow Express is a different project to Terminal 5. It may have worked there, but it's never going to work on here. So John Egan put out a competition, gave out a competition, and he gave us this building, which is called the People Building by an architect called 3D Wheeler. And they were building 5 of these. They'd already built 2. And following the Egan principle, put a team on it, build it, find out what you've done wrong, change what you're doing, and do the building the second time. We will reduce the cost. And in fact, that did happen. However, the building was still delivered at 25% more than the original price suggested. So although the price at tender was reduced, the outcome was still 25%. We did the third building using the processes and methodology, and we reduced the cost of the building. We got rid of half of the waste. The fourth building, for whatever reason, which I never understand, was given to another team. The outcome of that was, without using the processes, the price went up again. The 25% waste came back into those projects. So process with the technology, with a collaborative attitude, will deliver better results. This didn't stop. 1994, just before Terminal 5, the Labour report was put out. The figure has now gone up to 30%. The industry with the technology is getting worse, not better. It's not even standing still. The government has decided it is no longer willing to pay for the waste and the incompetence, to some extent, of the industry. So its challenge is being conservative. Labour says 30%, we say 25%. They're saying, get 20% out of this. I am not going to pay for the waste anymore. So on all publicly procured projects by 2016, you must follow the processes that brought us to this position. And those processes are basically known as BS 1192-2007, and now the PAS 1192 Part 2. We will come back to those documents a bit later on. So the government as client no longer, or as clients, are no longer willing to pay for the waste. And this is public money. Why should we be paying for our industry's incompetence? So we come to this whole idea of what is BIM. Let's ask the question earlier on. As far as the snake oil salesmen are concerned, it's 3D modelling and visualisation. Crash detection, the low-hanging fruit. Shown does not work. What the government chooses to do is it's had to use the acronym because it's something everybody will focus on. And we will slowly get rid of it in there. It's about collaborative work. And the standards that we produce always start off with a collaborative method. Okay, so what we mean by BIM is the combination of all the discipline-specific models with additional appropriate information produced by the designers, contractors, specialist designers, fabricators, installers, facilities managers, and the asset manager to link to the production information model, BIM, which will be delivered at the end of the project into the AIM, the asset information model. So that is what we mean by BIM. Not just, in fact, if you look at this in percentage terms, the 3D model is about 5% of the data that we're going to deliver at handback. 95% is a massive amount of additional information about this asset, about this project, how to maintain it, what its performance requirements are. So this is about data procurement now, not just about building procurement. We want the building, but we also want the data associated with it, good quality information, checked and suitable for purpose, delivered at the end of the project. Handover from PIM to AIM, project information model to asset information model. So it's the model, it's the data plus the information, whatever you like to call it, plus the model, not just the model on its own. And as I just said, the processes for delivery are defined in BS 1192-2007. Put this slide up there, even though I've just specified it, is because it's quite important. This is 2007. The government strategy was not put together till 2011 and was based on the wedgie diagram, which we'll have a look at in a moment. And the point about this is that the government paid for this to be written. The government paid us to take what we knew and The government had paid for research over a 20-odd year period, running back into the 1990s, to come up with answers for a better way of working. We had done it, we tested it through the Heathrow Express, etc., and we then, because of the results of that and the savings that were made, we were asked to publish it as a British standard, a code of practice. Not a guidance document, a code of practice. And so BS 1192-207 was born and put out into the industry. Its uptake was minimal. Take that document, I'll put it on the top shelf, along with the pink and the green, and all of the other documents are sitting up on the top shelf. In writing the BIM strategy, we had to use that acronym, the government decided that this worked, this is measured, this is what I want people to do, so they have adopted this standard into the BIM strategy and enhanced it with PAS 1192. It is not something that's come out of the BIM strategy as such, so it was there before. In fact, 4 years before. It took us that long to get government running with this. It also provides a disciplined, managed approach to the delivery of models, drawings, documents, data and information, and coding. I'm not going to dwell on this. This is just a suitcase, an Excel spreadsheet, where we are going to deliver and how we are going to deliver the data into the client, handover or hand back to the client. The IT aficionados, up they come, backs up, bristling like nobody's business. We do that with a database. Well, you may be able to do it with a database, but government as client, and most of its offices, can't handle it yet. They don't have a database in which to put it. So we're delivering it in its simplest form, simplest and cheapest form, and that is just as an Excel spreadsheet. So that as government as client puts its IT solutions in place, it has the data which it will be able to download and populate these databases. So this is just a simple way of delivering it. And it's only about data. It's not delivering the 3D models or anything else. It underpins the government construction strategy. The reason this is here, it's not just because it's got my name on it, I wrote this one as well. Codes of practice, by their very definition, or by the way in which they're written, are quite thin. And they are very specific in what they only put factual information in. Do this, do that, do the other. For people to interpret that and understand what it's really going to do and how it really works is very difficult. And this is the problem we find with all of the BSs and the codes of practice. So there are guides written that will go with it. So PAS 1192, a guide is being drawn up to go with it. So this document is about that thick, and this document is 3-4 times thicker. This describes exactly what you should do and why you are doing it. Okay. I'm not selling it because I don't get paid anything for it. It was done free of charge. So you can go out there and buy it quite easily. One of the things that's come out of the government strategy is an understanding and a belief by those people that helped put it in place. So Paul Morrell, bless his heart, who took this on board in 2011, he had already been in office there for 2 years, understood what we were trying to do and got us to write all of this documentation and explain it into government, because we are also educating the government to become an intelligent client, as well as trying to get the industry to change the way it works and its culture. And his comment is this: we are only just beginning to understand the scale of what can be achieved and the amount of waste that can be eliminated from the system. So from these early adopter programs, he's already seen the value and the return that the government can get from this. It isn't just the government as client that's making money here, by the way. In all of the research that we've done, we've had to prove that the whole supply chain also makes money.